Alright, so welcome to another video. This one's called branched esters versus substituted esters. Now, in the VCE Chemistry Study Design for Unit 4 Area of Study 1, we have the following study design dot point, and part of this study design dot point includes the systematic naming of organic compounds that include or are limited to non-branched esters. What defines a branched ester and a non-branched ester? Well, let's say, for example, that we've got an esterification reaction. This reaction involves ethanol reacting with propanoic acid. Okay, so these are our reactants. We've got ethanol here and propanoic acid. This particular reaction will form a non-branched ester. So to name the ester, the hydroxyl group in the carboxylic acid will leave and it will form a water molecule, and a hydrogen from the alcohol will also leave to help form that water molecule, and the remaining two parts of these molecules will join together to form the ester. Okay, so essentially that is what the ester will look like. And we know how to name this already, right? Put that as a product. And, oh, actually, all right, so that's our ester that's formed. And obviously there is still water that has formed as well. So don't forget about the little water. All right, so how do you name this molecule? Well, the alcohol part of the ester is going to transform its name into an alkyl. So it will be, instead of ethanol, it will be ethyl. And the propanoic acid will have the suffix oate, so it will be propanoate. And so the name of this ester that has formed is going to be ethylpropanoate. This is a non-branched ester. Now let's do another example. Let's kind of copy this equation and change up these reactants a little bit. Okay, so now instead of having ethanol, let's just make this. Okay, so we've got a 2-methylpropan-1-ol reacting with propanoic acid. All right, so the name is going to change. It's not the ester that forms. It's not going to be ethylpropanoate anymore. Actually, because we've got 2-methylpropan-1-ol, we're going to have a methyl group on this second carbon over here, and we would consider this a branch. Okay, so this is a branched ester. This is a branched ester. You can definitely draw these. You'll know how to draw these. You're required to know how to draw these. You're required to know how to represent them in skeletal form and structural diagrams and condensed structural formulas and molecular formulas. But the study design says you'll never need to name these. Okay? However, it is very possible to have a molecule that is substituted, a substituted ester. So what do we mean by a substituted ester? So let's go and copy that diagram down again. And what we'll do is we'll change ethanol, we'll change propanoic acid, or one of them, and the name will change as well. And we're still going to have a non-branched ester. Okay? It will be a non-branched but substituted ester. Non-branched ester. Okay, but substituted. So what does that look like? A substituted ester is an ester that's going to have, for example, a halogen or an amine or a hydroxyl group as a substitute for one of the H's. So we can have this right here is 2-chloroethanol. Chloroethanol, right? And we can react that with propanoic acid. Let's just say, for example, we have an amine over here on the second carbon. How on earth are we going to name the resulting ester? Now we've got a chlorine that's on the second carbon of this side of the molecule, and we've got an amino group that is on the second carbon here. All right. So the names, well, what's the name of this carboxylic acid that formed the ester? 2-amino propanoic acid. Now this is not too deep. This is going to be actually very, very simple. Okay, so the 2-chloroethanol will just be 2-chloroethyl. It gets the same ending, right? We're just adding the 2-chloro in, that kind of prefix. And the propanoic acid is going to become 2-amino. So you keep the prefix, you keep that prefix, you keep that prefix, and then you just add the regular endings for the ester. So 2-amino propan, instead of propan oic acid, it is. So the name of this ester that has formed is, it's 2-chloro, 2-chloroethyl dash 2-amino propanoate. Okay. So some things to keep in mind. The carbons closest to the oxygens are always carbon number 1. Right, so this is carbon number 1 of the alcohol side. This is carbon number 2 of the alcohol side. This is carbon number 2 of the carboxylic acid side. This is carbon number 3 of the carboxylic acid side. So the way we kind of read this ester is 2-chloroethyl. That means the ethyl, or the alcohol side of the molecule, has a chlorine on the second carbon, which is right here. And the carboxylic acid has a 2-amino. So on the second carbon, there is an amino group on the second carbon of the carboxylic acid. All right, and that's pretty much how you would name these types of esters. Now, why does this matter? Not only is it that the study design suggests that we should know how to name these things, but also VCAA in 2024 gave us a question like this, right? And so the question was multiple choice, question 21. Which of the following represents the skeletal structure for 3-chlorobutyl butanoate? Now, not many textbooks would have taught you how to name or how to recognize such a molecule. So it's going to be very important for us to learn it ourselves. Okay, so how do we solve this question? Well, if you have a look, the ester always has 2 parts. Okay, there is a carboxylic acid part, which is coming from the oate part of the name. So butanoate means that it came from a but and a carboxylic acid with 4 carbons, so a butanoic acid. And the 3-chlorobutyl is the alcohol part of the ester. And but means 4 carbons as well. Butyl means 4 carbons. So it must have come from a butanol. All right, butanol. It must have come from a butan-1-ol, actually. It must have come from a butan-1-ol. Now, how do I know it must have come from a butan-1-ol and not a butan-2-ol? If you have a butan-2-ol, then you're going to end up with a branched ester, an ester with alkyl side group. Okay, so that's not in the study design. So it must have been butan-1-ol. And there was a chlorine on the 3rd carbon, so it came from a 3-chloro butan-1-ol. Okay, these were the 2 reactants that were used to make this particular ester. In total, there are 8 carbons, right? There are 4 carbons over here from the butan-1-ol, and there are 4 carbons over here from the butanoic acid. So both sides of the molecule, alcohol side and carboxylic acid side, must have 4 carbons. Let's have a look at our options. Option A, we've got our carbon double bond oxygen over here. And so this side of the molecule represents our carboxylic acid side. And we can see that on the 1, 2, 3, the third, well, actually, there are how many carbons in here? There's 1, 2, 3, 4, 5. So that is straight away wrong. We can just cross that out because there are only meant to be 4 carbons for the carboxylic acid side. Let's have a look at B. So B, there is 1, 2, 3, 4, 5. Again, that is wrong. Now have a look at C. Well, there's a carbon there. 1, 2, 3, 4. Okay, that looks promising. There are 4 carbons, right? But we have the chlorine sitting here. The chlorine is currently on the carboxylic acid side of the molecule, but we know that it came from butanoic acid, and butanoic acid has no chlorine group attached to it. So it can't be C. It must be D, but let's just give ourselves some extra conviction in our answer. So we have here the carboxylic acid side, starting from the carbon double bond O. There's 1 carbon, 2, 3, 4 carbons. That checks out. There's no side groups. That means that is butanoic acid. We've got on the alcohol side the oxygen, which is bonded to a carbon sitting right there. Keep in mind, this is a very, very common mistake. Some students will think that this little point over there is a carbon. That is not a carbon. Not a carbon. Just keep that in mind. Okay, so there's 1 carbon there in red, that red dot, 2, 3, and 4. There are 4 carbons there. And on the third carbon, this is carbon 1, 2, and this is carbon 3, this is carbon 4. On the third carbon, we have that chlorine group, and that represents our 3-chloro-butan-1-ol. Okay, so the answer is D. Now, let's try to name a couple more. So, examples of sub. Okay, so let's start off with some skeletal diagrams. All right, so if we have an ester like this, we will go ahead, and the way that I name the ester is first I find where the carbon double bond O is, and that is sitting right here. And I trace back how many carbons are attached to it. So that's 1, 2, 3, 4, 5. There are 5 carbons in this. And remember, the carbon double bond O is the carboxylic acid side. This is the carboxylic acid part of the molecule. Okay, so this carboxylic acid part must have originated from a pent, 5 carbons, right? So a pentan, a pentanoic acid. Now the alcohol side of the molecule is everything to the left of the oxygen inside the chain. All right, now just remember that this green dot over here is not a carbon. That is not a carbon. Okay, so we have a carbon over here. That's 1, 2, 3, 4, 5. There are 5 carbons here as well. So this is also a pentan. All right, now remember, it has to be a pentan-1-ol. It's got to be a pentan-1-ol, because this here is carbon number 1, and this here is, or was, the hydroxyl group, okay, the OH. So that's carbon 1, that's carbon 2, 3, and 4. This is 5. So that means it's a 4-bromo. So when we name the ester, we're simply going to combine these 2 parts, and you always list the alcohol part first. And the 4-bromo-pentan-1-ol becomes 4-bromo-pentyl. Remember, the alcohol part becomes an YL. So 4-bromopentyl pentanoate. Okay, let's try another example. So in this example, we have a chlorine group over here, and we've got a hydroxyl group over here, which is on the carboxylic acid side again. So how do I know that? Well, again, I find the carbon double bond O, which is right here, and I trace back. So we've got 1 carbon, 2, 3, 4, 5, 6. There are 6 carbons in this side of the molecule, and this side is the carboxylic acid side. Okay, this is our carbox acid. All right, 6 carbons means it's a hex. So hexan, it's a hexanoic acid. And now this is carbon number 1. Always the carboxylic group, carbon is always carbon number 1. Carbon 2, 3, 4, 5, and 6. So that means we've got a hydroxy on the carbon number 4. So this is actually, this carboxylic acid side is called 4-hydroxyanoic acid. All right. Now the other side, well, we've got 1, 2, 3. So this is, and there's a chlorine on carbon number 2. Remember, this is carbon number 1. So this would be 2-chloro-propan. Okay, 2-chloro-propan-1-ol. So the names change, and the 2-chloropropanol will become, and they change and they merge together. So the 2-chloropropanol will become 2-chloropropyl, and then the 4-hydroxyhexanoic acid will become 4-hydroxyhexanoate. All right. Let's do one more example. Okay. So again, when the strategy is find the carbon double bond O, which is right here, carbon double bond O, right? And we're going to trace back to see how many carbons are in this carboxylic acid side. Now, this example is flipped compared to the first couple examples I've given. The carboxylic acid side is actually going this way. So you always find the carboxylic acid side, right, by tracing back from the carbon double bond O. All right, so this carboxylic acid side has 1, 2, 3, 4, 5, 6, 7 carbons. So this is a heptanoic acid. It's not just the heptanoic acid. We've got an amino group on carbon number 4. So this is 4-amino heptanoic acid. The alcohol side, what does that look like? Well, there is 1 carbon, 2, 3, 4. And there's an amino group, so that's carbon 1, 2, 3, and 4. Amino group on carbon number 2. So this is a 2-amino butanol, right? So the name of the ester, remember that the alcohol part of the molecule is going to be listed first, and then will come the carboxylic acid part of the molecule. So the alcohol's name will become, from 2-amino butanol, it will become 2-amino butyl, all right, and then the 4-amino heptanoic acid will become 4-amino heptanoate. All right, that is the name of this substituted ester. All right, so that was a video on how to name substituted esters. If you would like more resources like worksheets or written guides on how to deal with scenarios like this, please head to the website beyondthebond.com.au and visit the links in the description. And if you like this video, give it a like and subscribe, and I'll be posting more content, so stay tuned.